Pursuing scientific knowledge is a journey transcending mere facts and figures. It is a dynamic interplay of observation, reasoning, and the relentless quest for understanding. Scientific knowledge is not static, but develops through rigorous methodologies and critical thinking. To appreciate the true nature of scientific knowledge and reasoning, one must delve into its historical roots, the processes that underpin it, the significance of reasoning in scientific inquiry, and the implications for education and decision-making. This exploration reveals that scientific knowledge is as much about the questions we ask as it is about the answers we find. The historical context of scientific knowledge. The foundations of scientific knowledge can be traced back to ancient thinkers like Aristotle and Eratosthenes, who, despite not identifying as scientists in the modern sense, employed systematic observation and logical reasoning to understand the world around them. Their contributions laid the groundwork for what would eventually grow into the scientific method. For instance, Eratosthenes famously calculated the Earth's circumference using simple geometry and observations of shadows cast by the sun at different locations. This historical perspective underscores that scientific inquiry was rooted in observation and reasoning long before formal methodologies were established. As science progressed through the ages, it became increasingly clear that knowledge is not a collection of isolated facts, but a web of interconnected ideas. The Renaissance and Enlightenment periods marked significant advancements in scientific thought, with figures like Galileo and Newton introducing empirical methods and mathematical reasoning into their work. This shift emphasized the importance of experimentation and evidence in validating hypotheses. The development of the scientific method as we know it today, characterized by systematic observation, hypothesis formulation, experimentation, and analysis, was crucial in transforming how knowledge was acquired and understood. The processes of scientific reasoning. At the heart of scientific knowledge lies a complex array of reasoning processes facilitating inquiry. Induction and deduction are two fundamental forms of reasoning that scientists employ to conclude from observations. Inductive reasoning involves generalizations based on specific observations, while deductive reasoning applies general principles to predict specific outcomes. Both processes are essential for developing theories and testing hypotheses. Moreover, scientific reasoning encompasses experimental design, causal reasoning, concept formation, and hypothesis testing. Each component is vital in ensuring that scientific investigations are robust and reliable. For instance, effective experimental design minimizes biases and controls variables to isolate causal relationships. This meticulous approach enhances the credibility of scientific findings and fosters a deeper understanding of complex phenomena. The interplay between these reasoning processes highlights that scientific knowledge is not merely about accumulating information, but about understanding relationships, making predictions, and refining theories based on new evidence. This iterative process distinguishes science from other forms of knowledge acquisition. The role of reasoning in scientific inquiry. Reasoning is scientific inquiry's backbone, enabling scientists to navigate uncertainty and complexity. The ability to critically evaluate evidence, recognize patterns, and formulate logical arguments is paramount in advancing scientific knowledge. This skill set is not limited to professional scientists. It is essential for anyone engaging with scientific concepts, particularly in an age where misinformation can quickly proliferate. Understanding scientific reasoning also has profound implications for education. Teaching students to think scientifically equips them with the tools to tackle real-world problems. By fostering an environment where questioning is encouraged and critical thinking is prioritized, educators can cultivate a generation capable of making informed decisions based on evidence rather than conjecture. Furthermore, scientific reasoning becomes crucial for informed decision-making as society grapples with socio-scientific issues, such as climate change, public health crises, and technological advancements. Individuals who comprehend the nature of scientific knowledge are better positioned to engage in discussions about these pressing issues, ultimately leading to more thoughtful and practical solutions. The implications for society. Understanding scientific knowledge has implications beyond academia. They permeate every aspect of society. In a world increasingly driven by science and technology, citizens must possess a foundational understanding of scientific principles to navigate contemporary challenges effectively. This necessity underscores the importance of integrating scientific literacy into educational curricula at all levels. Moreover, as individuals engage with socio-scientific issues, their ability to reason scientifically empowers them to participate meaningfully in public discourse. Whether advocating for policy changes or making personal choices regarding health and safety, informed citizens can contribute to a more rational and evidence-based society. This collective understanding fosters a culture where science is valued for its discoveries and role in enhancing human well-being. In conclusion, the nature of scientific knowledge and reasoning is a multifaceted construct that has evolved over centuries. It encompasses historical perspectives, intricate reasoning processes, and significant implications for education and societal engagement. As we continue to advance our understanding of the world through science, it is imperative that we cultivate a culture that values critical thinking and evidence-based reasoning. By doing so, we empower individuals to confidently navigate complexity and contribute positively to society.